Hi everybody. This video we are going to solve the following equation. It is the tangent of x plus pi plus 2 sine x plus pi equals 0 for x is between 0 and 2 pi. And this falls underneath the umbrella of the unit or topic that we're working on with angle, sum, and difference identities. So that means that we are going to be using angle, sum, and difference identities. Here and here I have a sum of, that's an alpha plus beta, something plus something. Where we have alpha, I suppose we could call it, we have an x or a variable, so that part will not get fully evaluated, and that will be the main element of us solving. So that's the x we solve for. But the beta is a pi or a constant value. So we will be evaluating everywhere that we are implementing that beta. So tan of beta, sine of beta, cosine of beta, whatever it might be. Since we have pi, we're going to be finding either the sine, the cosine, or the tangent, whatever it may be, of pi. Hopefully we all remember pi is equal to 180 degrees. It's going to land all the way over here on the unit circle. The ordered pair at that point was -1, 0. That means that cosine is -1. That means that sine is 0, and tangent is also 0 if you remember tan, the meditating man. So we'll cross those bridges when we get to them. Let's get started. I guess what I could do to begin is I'm going to use the tangent identity myself. I think it's just cleaner, less messy. So I will have tan of x plus tan of pi. It looks like you distribute tan when you do this identity. That is not a thing. You would never, ever, ever, ever do that. And then on bottom, denominator, 1 minus the product, tan x tan pi. Remember, we just said the tangent of pi is 0. So in the next step, we're going to fill in a 0 right there. We're going to fill in a 0 right there. But that'll be the next step. Plus 2 times, all this equals 0. All right. Here, sine, angle, sum. Sine keeps the same sign. So if that's plus, then this will be plus as well. Sine x, cosine pi, and then a little change around. Cosine x, sine pi, product and product. The cosine of pi, we just said, is going to be -1, next step. And then the sine of pi is 0, also next step. From here, we will have, cleaning up, tan x over 0 times anything is 0. 1 minus 0 is 1. Did I need to write that? No, I could have just written tan x, whatever. Plus, so we could just do this. So it's there, but it's not there. 2 times sine x times -1. I'm just going to write negative sine x. And cosine x times 0, well, that's really just plus 0, equals 0. Clean this up a little bit more. Tan x minus 2 sine x is 0. Now, it's a little awkward at this point, and there's a few options that you have to solve this. You want to kind of channel things that we did when we did trig identities, and one of the things that we did was we changed everything into sines and cosines, and that helps you kind of see things a little bit more clearly. Tangent, I'm going to rewrite it as sine over cosine. What this will allow me to do in the next step is I will be able to factor out a GCF. We always want to factor when we can solve. I feel like not enough people associate solving with factoring enough. Factoring is key to being able to solve equations that are more multidimensional, that have more depth to them. So when you have a lot more going on, you have more types of functions in it, you have higher degree expressions in it, factoring is key. We want to have like almost a first degree linear style expression set equal to 0 when solving. And this is tangent. It's like a different function being implemented. Let's clean it down and put everything to look at all the same ingredients out on the counter here. So I'm going to factor out sine x. Now, when I do that, Some people are going to have to show 1 over cosine x. That's fine. And then that's minus 2. Other people will skip this step a bit and are going to jump. Instead of writing 1 over cosine, they're going to write secant right away. All right. And you may have done it differently. It doesn't mean you're wrong. So we'll see if you got the same answer in a different way. So still have sine x out front. And then this is secant x minus 2 is 0. So now this is a factor, sine x. We usually don't put parentheses around it, but it truly has them. So we have sine x, and then we have the other factor, secant x minus 2. So we are going to use the zero product property, just set each of these equal to 0 and finish from there. So when does sine of x equal 0? Maybe you took sine inverse on your paper. You like what that looks like, sine inverse of 0. But either way, this is asking you the sine of what angle or angles between 0 and 2 pi. The sine of what angle or angles is equal to 0. Where does y equal 0? Here and here. So when x equals 0 and when x equals pi. You do want to be careful with a bunch of these though, because you might get an answer that if you took that answer and plugged it back into the original problem, might cause for part or the entire problem to be undefined. And if that happens, you have to make that an extraneous solution and throw that out. So definitely keep your eyes peeled, because if you solved it in another method and maybe you get all the answers I got plus an extra answer, check, was your extra answer extraneous? Should you have gotten rid of it? So always keep that in mind. When your original problem only had sine and cosine in it, you're pretty much in the clear because it's never going to be undefined. You could plug in any x, any angle. But when you have any of the other 4 trig functions, so cosecant, secant, tangent, and cotangent, those have places where they're undefined. They have asymptotes. So you need to know that when you solve that equation that you don't find an answer that happens to be at an asymptote. That would be a throwaway. Sorry for the long-winded explanation. Secant x minus 2 is 0. And also, they're not always going to tell you, check for extraneous, like that's on you. Secant x equals 2, that's exactly the same as saying cosine x equals 1/2. Some people might prefer to look at it that way. Ooh, I'm so off to the edge there. All right, and then, let's do that. So we fit everything. And then x equals cosine inverse. You might hear it called arc cosine, A-R-C-C-O-S. That's the same as cosine inverse. I don't know where I got it from, where I would always say like arc cosine's the old-fashioned way to do it, and then cosine inverse with the -1, that's like the more modern way to do it. I straight up could be making that up, but a colleague of mine from my previous job that I worked with for almost 15 years, and she's been teaching for like 40 years, she actually says the exact same thing. So unless we both made it up, I don't know. So cosine of what angle or angles is equal to 1/2. Cosine is an x value, so it's going to be an angle here and here. Again, we were asked to find answers between 0 and 2 pi. So what angles are that? Tall and skinny like a tree. That's when x equals pi over 3. And when x equals 2, 3, 4, 5 pi over 3. So it looks like I got myself, hopefully I didn't make any mistakes myself on this, but it looks like I got 4 answers: 0, pi, pi over 3, and 5 pi over 3. Hopefully you guys got the same. You may have used the sine over cosine version of this, perhaps, but you should still get the same answer. Maybe you got an extra extraneous solution that you had to get rid of. If you understand and got the same answer, you could do a thumbs up. If you got different answers, made a mistake, or don't understand, put a thumbs down so I could stay organized. Any questions from the remaining people observing? Or are you good to go? You think I addressed everything on here?
Yep, that makes sense.
We're good? All right. All right.
Yeah.
You're good? Okay. So that's the end of this recording, and have a nice day.